What do we mean when we say all real numbers? Well, when people think of all real numbers, they begin to think about these numbers right here. Um, 0, 1, 2, 3, 4, and on, and the negatives, negative 1, negative 2, negative 3, negative 4, and all the way back. But those aren't really the real numbers. These are actually the integers, okay? Um, the real numbers, let's take a look at what those are. They're made out of two sets of numbers. First, they're made out of what we call the rational numbers. 4 is a rational number. The definition of a rational number is any number that can be represented by integer over another integer. And I can represent 4 as the integer 8 over the integer 2. I can also represent 4 as the integer 100 over the integer 25. Therefore, that makes 4 what we call rational because it can be represented by integer over integer. Zero point 0.4 can also be represented by integer over integer, 4 over 10, or even 2 over 5. 0.44 repeating can also be represented as an integer, 4 over 9, or 8 over 18. In fact, any repeating number can be converted into an integer over another integer. Roots. Only certain roots can be rational. This root 9 is a perfect square. The square root of 9 is 3. Therefore, 3 can be represented as 3 over 1. It makes it a rational number. So square root of 9 is a rational number. It's a special one because it can be simplified. Negative square root of 4, because 4 is a perfect square, it can be simplified to a 2. Therefore, it can be represented by negative 2 over 1, which is an integer over integer, or just negative 2. Now, numbers that are not rational, we call those irrational. Numbers that cannot be represented by an integer over integer. Now, how do we know we have one of those animals? Well, something that cannot be represented as an integer over integer has decimals, and those decimals are non-repeating. 3.14 followed by non-repeating decimals would be an irrational number. 2.17 followed by non-repeating decimals would be irrational. 1.72 followed by non-repeating numbers. 1.14 followed by non-repeating, and negative 7.07 followed by non-repeating. These are all irrational numbers. And because they have all these numbers that are non-repeating, we can figure out what those numbers are, or what's going to come next, but most people don't know them. Therefore, we just simply symbolize these irrational numbers. So 3.14, that's the famous one, 1592, etc. We symbolize that as pi. 2.17, with all its non-repeatings, we symbolize that as the letter E. 1.72, with more numbers behind it, that's the square root of 3. 1.14 with non-repeatings, that's the square root of 2. And the infamous negative 0.707, we knew that well from trig, that's negative square root of 0.5, or we tend to call that negative square root of 2 divided by 2, same number. So again, we tend to symbolize our irrationals because they are not writable. So all the real numbers are represented by the combination of the rationals and the irrationals. The rationals are basically made from using integers. So underneath the rationals, we'll find the integers, which are the numbers we started off with, 0, 1, 2, 3, 4, etc. And going the other way, negatives, 1, 2, 3, 4, all the way back to negative infinity. Now, if we were to remove all the negative numbers and just use the 0, 1, 2, 3, 4 on to infinity, now we have what we call the whole numbers. Whole numbers are the integers without the negatives. Now, if we stop using the 0 and just use the 1, 2, 3, 4, now we have the natural numbers. Okay, so natural numbers are the whole numbers without 0, whereas the whole numbers are the integers without the negatives. In reverse, all the natural numbers are inside the whole numbers. And all the whole numbers are inside the integers, and all the integers are inside the rational numbers. And the rational numbers are all inside the real numbers, in addition to all the irrational numbers. So the real number system holds all your rationals and your irrationals at the same time. Irrationals plus rationals is all the real numbers. So let's take a look at a chart here. All numbers are going to be real. So the 9 is and -9 and everything else is checked off as real. But are they rational, irrational, integers, whole, or natural numbers? Well, 9 is a rational number because I can represent 9 as an integer over integer. 18 over 2, or 90 over 10. It doesn't have the crazy decimals that are non-repeating, so it's not irrational. But it is part of the integers, because remember the integers are your counting numbers, 0, 1, 2, 3, 4, 5, and -1, -2, all those. It's an integer. Also the whole numbers. 9 is in the whole numbers. 9 is also a natural number. -9 is a rational number. I can write that as an integer over integer. -9 over 1. It's not irrational. It is an integer because the integers use the negative numbers, so it goes back to -1 all the way back to -9. So it's an integer. The whole numbers don't use negative numbers, so -9 is not a whole number, and the natural numbers don't use negative numbers as well. Now the square root of 9 is a perfect square, so that'll simplify to a 3. So we're really talking about 3. 3 is rational, because you can say that's 3 over 1. It's an integer. Integers are those numbers 0, 1, 2, 3, so it's there. It's also a whole number, because whole numbers start with 0, 1, 2, 3, and keep going, so it's in there. And natural numbers, because you have 1, 2, 3, it's there as well. 0 is definitely a rational number. I can write 0 as 0 over 10, and that's an integer over integer, so it's rational. And it's also part of the integers. It's also part of the wholes. The wholes use 0, but the naturals don't use 0, so 0 is not a part of the naturals. The square root of 8. 8 is not a perfect square. Therefore, when you try to simplify it, you're going to get a lot of these decimals and decimals that don't repeat, so it's not going to be rational. It's going to fall under being irrational and nothing else. 2 times the square root of, 2 times pi. Pi is irrational, so 2 of the irrationals just still stays irrational. So it's irrational and nothing else. 3.3 repeating. Remember, the repeating decimals can be converted into integer over integer. In particular, this can be converted into a 10 over 3, which is a rational number. So it won't fall under irrational. It also won't fall under integers. Integers are just the numbers 1, 2, 3, 4, 5, and -1, 2, 3, 4, 5. So you can't get the fractions with the integers. And definitely not whole or natural. So it stays at being just a rational number.